Hello, my name is Adam Gladstein, and our group was assigned to the Framingham Heart Study. Before we get further into the slide deck, let's establish what the Framingham Heart Study is. The Framingham Heart Study is one of the longest running health studies comparing the blood pressure between males and females. It follows original subjects, their children, and grandchildren. There are currently over 15,000 individuals partaking in the test. It looks for factors that affect cardiac health by measuring through serial carotid ultrasounds, echocardiography, arteriotonometry, and imaging of cardiac structure, central arterial, and coronary. The data only includes subjects whose cholesterol was measured in their first exam. After looking over the data set, we have decided to investigate if there is a difference in the average systolic blood pressure in males and females. Now you might be wondering, what is systolic blood pressure? Systolic blood pressure is the top number in the blood pressure reading. It indicates the maximum pressure in the arteries when the heart contracts and pumps blood in. Contrast, the bottom number measures the pressure in the arteries between heartbeats. A normal systolic blood pressure reading would be anything below 120 millimeters of mercury. Now you may be thinking, why should I care about these random numbers? Because it is important to take your health into your own hands. Although your doctor tries their best, no one knows your body like you. Understanding what these numbers mean is crucial in taking your health numbers into your own hands. It also will tell you if your blood pressure is high. Having high blood pressure can damage your arteries, leading to serious complications such as heart attacks and strokes. Knowing if you have high blood pressure or on track to have high blood pressure is good to know. Once you know your numbers, you're able to see if you're at risk for heart attacks and strokes, which can lead you to changing your lifestyle, whether that be changing your diet or increasing exercise. Here are some famous celebrities who have dealt with high blood pressure. Whitney Houston, the famous singer and actress, died from drowning along with heart diseases, which was linked to undiagnosed high blood pressure. Billy Mays, the salesman, died on June 20th, 2009, and he died due to untreated chronic high blood pressure. On a better note, Oprah Winfrey used to suffer from high blood pressure due to her unhealthy lifestyle and diet, but once she made the right changes, she managed to put her high blood pressure under control. Before we look into the SAS outputs of our data, let's talk about the data itself. For our study, many of our variables were appreciated due to their long names, so let's go over them and what they stand for. All the data we have were taken at the participant's first exam. SBP represented the systolic blood pressure, which was the top number of the blood pressure reading. DBP represents the diastolic blood pressure, which is the bottom number of the blood pressure. CHOL represented the serum cholesterol, which is the total amount of cholesterol in the participant's bloodstream. FRW represents their Framingham relative weight, a standardized measure of weight that was adjusted for sex and height. CIG, which represented the number of cigarettes smoked per day. Death represents the number of participants who missed the first biannual exam due to death. The cause of death was then numberized. 0 meaning the participant is alive, 1 being death. 2 representing not sudden coronary heart disease, 3 representing stroke, 4 representing another cardiovascular disease, and 5 being cancer, and 6 representing others. All right, our null hypothesis was there is no significant difference in the average systolic blood pressure in males and females. In symbols, it is represented as mu1 equals mu2. Our alternate is there is a significant difference in the average systolic blood pressure in males and females. In symbols, it is represented in mu1 does not equal mu2. We did a two-sample t-test that compares the mean of the two groups, assuming they have equal variance, which is why we use the pooled method. The t-test measures how much the sample differs relative to the variability in the data. We got a t-value of 5.45. Due to it being quite large, it suggests there was a substantial difference between the two groups. The p-value tells us the probability of getting a t-value this extreme. assuming the null hypothesis is true. Our p-value is less than 0.0001, and because it's less than 0.05, it leads us to reject the null hypothesis. In context, our p-value is telling us that the average systolic blood pressure in males and females are different. Center shape, spread, distribution comparison. The top two graphs are a histogram, and the bottom are box plots. Each graph is labeled as either female or male, female representing females, male representing males. When looking at the center, we can see that the female center appears to be slightly above 140 millimeters of mercury based on both the histogram and the peak of the box plot center, while the male center is slightly higher than females, being closer to 145 to 150 millimeters of mercury. From this, we can assume that males tend to have a higher average systolic blood pressure than females. We'll look at the shape and distribution of females. The distribution looks normal, but shows a slight right skewness. This is indicated by the right tail. The histogram is moderately symmetrical, but there are some outliers suggesting some deviation from perfect normality. The male distribution is more clearly right skewed, as the peak is a bit sharper and there is a longer tail to the right. This suggests there are more systolic blood pressure outliers. Both histograms are slightly right skewed, but males have more pronounced skew with more extreme high values. When looking at the spread for females, most of the values are between 110 and 190 millimeters of mercury, with some outliers going all the way to 260 millimeters of mercury. The box plots show a moderate interquartile range, and the whiskers indicate a relatively contained variability with a few outliers. When looking at the spread for males, the value range from around 110 to 250 millimeters of mercury. It has a wider spread and more outliers when compared to the females. The box is also slightly wider, suggesting more variability. Based on the height of the histograms, both groups appear to have a similar sample size. Furthermore, the box plot width suggests that the group size are comparable. All right, based on the pooled method, the confidence interval was 5.1727 to 10.9856, while the other method's confidence interval was 5.2009 to 10.9573, right below pooled. The reason the confidence interval is slightly different in the methods is due to the fact that the pooled method takes the arithmetic average of the standard deviation and converts it to a standard error, while the other method calculates a standard of error from the weighted average of the two variances. The 95% confidence interval for the difference in average systolic blood pressure between females and males is 5.17 and 10.99. This means that we are 95% confident that the true difference in systolic blood pressure between females mu1 and males mu2 is between 5.17 mmHg and 10.99 mmHg, with females having higher blood pressure than males. Since the entire interval is positive, does not include 0, we can conclude that there's a significant difference, with females having higher blood pressure on average. Both the confidence interval and p-value tests led to the same conclusion. The confidence interval of 5.17 and 10.99 is entirely positive and does not include 0, indicating a significant difference between males and females, with females having high blood pressure. Similarly, the p-value of 0.0001 is much smaller than 0.05, which indicates that we reject the null hypothesis, supporting the conclusion that there is significant difference. In both cases, we conclude that females have higher average systolic blood pressure than males. So some limitations of the study is that the study could potentially favor subjects who are healthier during the first exam, as it only measures the cholesterol of them in the first exam. The study also does not include the socioeconomic status of individuals. The socioeconomic status of individuals impacts the food and resources they have available to them. SAS can run a bunch of different types of tests, so let's go over the ones we used and why. First one is proc means, as it provides a summary statistics such as the mean, median, minimum, maximum, and standard deviation, and the sample size. We use proc mean to begin to understand our data. We specifically asked SAS to calculate the mean, standard deviation, and sample size of average symbolic blood pressure by sex by adding mean, standard deviation to the line of code. Another one we used was proc univariate because it gives us a descriptive statistical analysis. It computed the mean, median, mode, standard deviation, variance, skewness, and normality. We use QQplot SB2 and we use QQplot SBP. We also used proc SGplot to create side-by-side box plots of symbolic blood pressure by sex. We used VBox to create vertical box plots as it gave us a visual summary of the data distribution. Specifically, it gave us the median, interquartile range, and outliers. In addition to proc SGP or SGpanel, it gave us a histogram of the symbolic blood pressure. It divides the data into panels based on the values of classification and creates separate graphs for each panel. In our case, it divided the data into female and male. And finally, we of course used proc t-test as it performs a two-sample independent to compare the systolic blood pressure. We use it to determine if we should reject or fail to reject the null hypothesis. So, and that is it for us. Delaney and Noah did the worksheets. Me, Adam, and Emily created the slideshow. Emily created the script, and I am doing the voiceover.